So 5.3 is solving linear systems using elimination. This is our third way of solving. So up until now, we have done graphing and we've done substitution, and now we're going to do elimination. So when I talk about elimination, we're actually going to cancel out one of the variables. So steps to solve, basically we're going to make sure our equations are lined up, and we would like them in the ax plus by equals c format, so standard form. So step 2 is going to be, we're going to add or subtract equations to eliminate a variable with a common coefficient. Okay, actually what we want to do is we want to make them exact opposite coefficients. So we want exact opposite coefficients. So I want one to be positive, one to be negative, so they actually cancel each other out. Step 3 is we're going to solve the equation for the remaining variable. So after when something cancels, you're only going to have one variable. So at this point, one variable. And we're going to solve the equation, just like we've solved equations for like ever, it seems like. And then we're going to substitute that answer back in to one of the either original equation. And then we're going to solve for the other variable. So if this one is x up here, then this one's going to be y. If this one is y, you're going to plug it in and solve for x. Now, what that looks like is this. So using addition to solve the systems of elimination, basically, I'm going to put a line down here so we can kind of keep them separate. Basically, we're just going to put a line underneath them, and we're looking at our x's, and we're looking at our y's. The y's are exact opposites already. So they will actually cancel, and I'm left with negative 3x plus 7x gives me 4x, which equals, just bring that down, and 8 minus 12 gives me negative 4. Divide by 4, I end up with x is equal to negative 1. This is where I am on step 3. Now I'm going to take that value, and I'm going to plug it right back in to one of my originals. So I'm going to choose this bottom one. I'm going to say 7, x value is negative 1, plus y equals negative 12. So negative 7 plus y equals negative 12. And I'm going to add 7 to both sides. So y equals, well, 7 would be 8, 9, 10, 11, 12. Gives me negative 5. So I end up with negative 1, negative 5. If I plug that into the other equation, it should work. If it doesn't, I know I made a mistake. But if I plug it in, so it would be negative 3 times negative 1 minus the y value of negative 5 equals 8. Well, this gives me 3 plus 5, which is 8. So yes, it all checks out, so it works. By subtraction, well, here's what I do with subtraction. Okay, so honestly, I like to combine like terms and have something cancel out. So when they say subtract, I actually would take this whole thing, because I'm looking at my y's, they're the exact same. I would subtract that quantity and rewrite it. So basically, I'm multiplying by a negative to give me 2x minus y equals negative 4. Now I can combine them and add. So kind of like what we did with integers, where it was like same, change to add. I'm actually going to just multiply through by a negative to switch all of those signs. Then now I'm going to combine. So basically add. So I end up with 3x, those cancel, equals negative 3. Divide by 3, x equals negative 1. I must like negative 1. We're going to plug that back in, and I would plug it into the easiest one, which would be x plus y equals 1. So negative 1 plus y equals 1. Add 1 to both sides. Y equals 2. So my solution would be negative 1, 2. So now we're getting into some actual example. Example number 1. Solve the following system using elimination, and then check your answer with the calculator. You don't even have to show it to me, but take the time to check it, because you should never get these wrong. I'm looking at these, and my y values can cancel because they're the exact same but opposite. So exact opposites. Just add them together. And I end up with 2x equals negative 2, x equals negative 1. Take it and plug it into one of the originals. It does not matter. I'm going to choose the top one. So 4 times negative 1 minus 3y equals 5. So negative 4 minus 3y equals 5. Add 4 to both sides. Negative 3y equals 9. Y equals negative 3, because divide by negative 3, divide by negative 3. So my ordered pair is negative 1, negative 3. I'm on page 10, so page 11. Starting in with B, I believe I only have 3 more examples for you. Okay, so as I look at this, they're already lined up, x's, y's, plain numbers. And my x's look like they're going to cancel, so I'm just going to put a line straight underneath them. Cancel that out. I get negative 4y equals, add those together, and I get 12. Divide by negative 4, y is equal to negative 3. Plug it back in. I'm, in this case, going to choose my bottom one because there are less negatives. So I'm going to say 5 times x plus 2 times negative 3 equals 4. 5x minus 6 equals 4. Add 6 to both sides. I get 5x equals 10. Divide by 5. X equals 2. So write it as an ordered pair, 2, negative 3. That is the solution. You can pause me and try these last 2 on your own. Keep in mind on this very last one, you're going to have to do some rearranging. All right. On C, this would be, actually, I would need to subtract because they're opposites, right? Or they're the exact same. So I'm going to multiply this bottom one by a negative. That's basically my subtraction. And I make it negative 7x plus 3y equals negative 4. And then I'm going to add. They cancel, and I'm left with 1y equals 1. So if y equals 1, I'm going to plug it back in. 7x minus 2 times 1 equals 5. 7x minus 2 equals 5. Add 2 to both sides to solve this. So 7x equals 7. X equals 1. So 1, 1. And the last one of this kind, I do need to rearrange. I need to make sure they're in ax plus by equals c format. So I'm going to move on this bottom one. I'm going to go minus 4x. So my bottom equation is changing to negative 4x plus 5y equals 6. And then I'm going to use this top one and the bottom one. My y's will cancel except I need to subtract. So I'm going to subtract this quantity. That makes that 4x minus 5y equals negative 6. So now I can use the top one and the bottom one. So 2x plus 5y equals 12, and 4x minus 5y equals negative 6. So I get 6x equals 6. X is equal to 1, so I divide by 6 on both sides. Go back to an original equation. So one of my originals, I would go with this top one that I have not touched and say 2 times 1 plus 5y equals 12. 2 plus 5y equals 12. Take away 2 on both. I get 5y equals 10. And divide by 5. So y is equal to 2. So 1, 2. And then it leads into our next set, which will be 5.4, because sometimes you have to do, not all of them are going to cancel as easily. So we're going to have to do some preliminary work, some multiplication of possibly even both equations. So it gets a little bit more in depth on those.